crazy, but like it's a physiological fact that when we get scared, we freeze, right? We want to slow down and get
Yeah.
more control over things. And so I feel like when things feel flaky, when they feel out of control, when they feel we add more process, we add more tests, we
Yeah.
add more stuff, we add more layers, and we don't realize that we're killing ourselves.
Today's guest is Charity Majors. Charity is CTO at Honeycomb and one of my absolute favorite writers. I believe I have recommended more articles from her blog than any other author on the newsletter. Today we talked about observability, testing in production, continuous delivery, developer experience, and much more. So let's dive right into it. Hi, Charity. Welcome and thank you so much for being here with us today.
Good morning. I'm very happy to be here.
Thank you. So, Charity, you are CTO of Honeycomb, which is an observability platform. And I
hmm
will let you define this and explain what it means. But let's say it helps engineers solve problems with their applications, right?
Yes.
And so I would love to start our chat by talking exactly about observability, because it's one of those things that can be kind of confusing for some managers, for some engineers, because we have been talking about different things with different names for many years. You know, we have monitoring, you have APM, you have, lower level, you have logging, all these kind of things. And now we are talking more and more about observability. And so you are one of the top experts about this. You run a company about this. You have written a book. So what's your definition? What is observability as opposed to, for example, monitoring?
I love this question. And my answer to this has changed over the years. When we started Honeycomb, we reached for the language of observability to really try and differentiate from monitoring. And we came up with this laundry list of
Yeah.
things like you need high cardinality and high dimensionality, and you need explorability, and it's about unknown unknowns instead of known unknowns. And then as the conversation grew, everybody else kind of started jumping in. It's like, well, we do or we do observability too. And nowadays, honestly, I've come around to think that observability is a property of complex systems, just like scalability, just like performance, just like
Hmm.
it's a property of complex socio-technical systems. And that means that if you add some metrics, you improve you improve your observability. If you educate your team on how to ask questions, you improve your observability. But I do think that there's a bit of a like if we flatten everything into being a property of complex systems, which I like, I think we also need to kind of account for the fact that there's been sort of a generational step function almost in terms of one of the definitions of observability
Hmm.
is that there's three pillars, right? Metrics, logs, and traces. Three pillars of observability. And so most of the existing APM tools are built on metrics. Most of the existing run tools are built on metrics. And most engineers are now capturing their data many different times. For every request that enters their system, they're capturing it for dashboards, for logs, for traces, for profiling. And nothing actually connects these tools except the engineer
Yeah.
who sits in the middle going, well, that spike looks like that spike. That shape, that timestamp is like that timestamp. Or maybe I'm going to copy paste ID from this tool to that tool. But like it's not connected. I feel like you now have a new generation of observability. So like we call this like observability 1.0 tools, right? And then I think there's observability 2.0 tools, which don't have many sources of truth. They don't have three pillars. There's just one source of truth, which is arbitrarily wide structured data blobs.
Yeah.
Sometimes some people call these canonical logs. You can also call them traces because that's all the spans are if you add some IDs.
Because if you have these wide events, you can derive your SLOs from them. You can derive your metrics from them. You can derive your dashboards from them. You can derive your logs from them. You can derive your traces from them. You can visualize them over time. You can zoom in. You can zoom out. You can
Yeah.
treat it like any other data, and and it's so much more powerful because it's like
Yeah.
being able to bring a scalpel to your tooling instead of only being able to sort of like group and then like you're just like you're guessing, you're taking a shot in the dark. And so when I think of observability 2.0 tooling, you know I think people are don't quite understand just how much data format matters. I mean, this is like the most cliche thing in all of it's like if your data model is broken, you're going to pay so much money and you're going to have so much
Yeah.
engineering overhead. And the model metrics are a very powerful tool, but they're a niche tool. They're very good for summarizing vast quantities of data. They're not a tool to help you explore the inner workings of complex systems. So my hope, I feel like in every other corner of the business, we've gone through this this change over the past few decades where we realize that what makes data powerful is its relationship to other data. And
Yeah.
the only place that we haven't really accepted that is when it comes to the most important data of all, which is our systems and application data.
Yeah, that's a great answer. And I remember you writing that observability is like the business intelligence of
Yes.
tooling, right? So, and it really resonated with my experience. I remember introducing BI first time in my startup, and it was like a moment of revelation, right? You don't even know that you can. What opportunities open up when you can correlate all the data in a single place and run queries about, uh, a, a wide scope of things that were not possible before. And you have said at the beginning that observability is first and foremost a property of the systems, right? And so I pick up a question from the chat immediately because I think it ties it very nicely. Because Clemens asks, do you need observability even when, for example, you're not dealing with microservices? And you think you can enlarge the scope of this question by saying, are there systems that lend themselves better or worse to observability? And so you should design things accordingly to enable the systems to be so.
Oh gosh, that is such a great question. Um, yes, I mean, well, yes. Obviously, the answer is First of all, I kind of wanted to touch on what you just. I'm all over the place here. I'm really excited by this question. What you just said about BI. So, like something that I feel like we all talk about silos, but what builds silos? I feel like the borders of tools are what builds silos. Any team that like uses a tool to interrogate its systems, when you're trying to talk to another team that uses a different tool, you spend more time arguing about the nature of reality than the problem that you're trying to solve
Yeah,
together. And so, like, I feel like it's so strange that we keep our application and systems data over here and our business data over there when we're building businesses with technology. And like, shouldn't they be the same thing? Shouldn't we be? So, like, one of the first things that one of our earliest customers did with Honeycomb was, I think it was Intercom, and they instrumented their, they built this nice little chat you embedded in websites, and they built this thing that they were on the verge of having to do this giant database migration because they had outgrown the largest EC2 instance size. And they're like, wow, this is probably we're gonna have to start it. It's gonna take us like a year. It's gonna be a big deal. They got Honeycomb. They instrumented their code with app IDs, famously high cardinality. You can't put that in the metrics. And then so one of the engineers was just kind of poking around and started breaking down and grouping by and went, oh shit. Uh, something like 75 to 80% of the execution time for this database is being taken up by one user ID who's paying us $20 a month. So we can either do this sharding migration or we can
wow.
throttle this dude or we can like, which is like to me such a great example of how our business decisions and our technical decisions are not separable. They're intertwined and our tooling should be
Yeah,
too. Um,
yeah.
so as to the question of microservices and so forth, I actually think it's kind of a perversion if you have to architect for observability. I think that observability, like, it's one of the things that bothers me the most about 1.0 tooling is how often you have to do that. Think about when you're
Mm,
using metrics and tags and you use the host name. And so you're super incentivized to have the fewer, larger host names because you can't pay for lots of small host tags without like 10xing the amount of money that you're spending. I think that's terrible. I think you should be able to architect your systems in the way that makes sense for your application, your users, your developers, without having to think about what's my bill going to be like for my observability and how am I going to be able. That said, I do think that there are some uh, technical decisions that serve kind of as cliffs almost,
mm,
where what you were doing was working just fine and all of a sudden it's not anymore. And I think
Yeah.
that for a lot of companies, microservices was one of those cliffs because microservices are a high cardinality dimension. If you're used to having 5 or 6 services, you can apply a tag for each service. Now, if you have 500, you can't. And so I think that, like, microservices is one that has been a tipping point for a lot of companies. I think being a platform provider is a huge one for a lot of companies. But like a lot of this stuff comes down over and over to, can you support high cardinality or not?
Yeah. Great answer. So what I'm hearing is that microservices particularly benefit because there is like a tipping point. Because without this kind of tools, you risk not understanding everything that is going on. But in
Well,
reality, since the point is breaking down silos, between product, between engineering, even I mean, without considering your systems, your architecture, you're benefiting from this because you're enabling even conversations that you cannot have otherwise. Is
yes,
that right?
exactly. I mean, if you think about it in the days of the monolith, do we need to understand our code and our users? Yes. But most of the complexity is bound up in your lines of code. What happened with microservices was we blew up the monolith, and all of a sudden, so much of the complexity exists. It's hopping the network. It's all over the place. You can't. So much of the problems are not how do I debug my code? It's where in the system is the line of code that I need to debug. And so, yeah,
Yeah.
when you're using microservices, you really you need to bring a lot of at the end of the day with the monolith, you could always attach it to a debugger, right? If all else
Yeah.
failed. But you can't do that with microservices. So yeah, you need some way of like ordering over time. But I would argue that it is just a forcing function and you do need it just as much with monoliths. It's just that you kind of hack along for a lot longer.
Yeah, yeah, I agree. So let's say you put yourself in the shoes of I mean, I'm thinking of the audience, people who are listening to these conversations, right? Maybe it's the CTOs or of smaller startups or people who are engineering managers in companies that still haven't adopted an observability solution or I should say an observability approach, right, to the way they're handling these problems. So how do you graduate, let's say, from monitoring to observing your systems? Is it just a matter of integrating a tool? Is it a matter of approach to how you do things? Or what you should do?
You know as well as I do that the answer is always it depends.
Of course.
but but I think that when I think this whole observability 1.0 versus 2.0 concept is something that's very like it's I've only been thinking about it in these terms for the past couple of months, and to me it kind of like it helps frame the debate in a very helpful way because according to semantic versioning, you are supposed to do a major version upgrade whenever you have backwards incompatible breaking changes, right? And so
Yeah.
going from multiple sources of truth to one source of truth is a backwards incompatible breaking change. But to achieve observability 2.0, it's not just as simple as you go from a monitoring tool to an observability tool. There's a lot of socio-technical things that are associated with observability 2.0. I think a lot of them you can use observability 1.0 tools to try and get very close to them, like using SLOs instead of paging people about symptoms all the time, right?
Yeah.
I think to really achieve observability 2.0 outcomes where you have the kind of tooling that allows you to really move very fast with a lot of confidence because your feedback loops, both in the individual level and the team level and the company level, are so fast and so sure footed. You need both observability 2.0 tools and you need the sort of practices and policies and habits and training. So like, I think most teams are stuck in or still trying to get to a place where they've really kind of mastered observability 1.0 and 2.0, but 2.0 is like it's the state where you're able to delete 90 to 95% of your paging alerts because you're aligning engineering pain with customer pain, and where your teams don't need to debug based off of page bombs because they can
Mhm.
rapidly find the answer to any unknown problem that crops up just by using the tools because the connective tissue is there in a shared source. So I think that the path that I see a lot of people take is they adopt an Observability 2.0 tool like Honeycomb as kind of a forcing function to help people
Mm,
start to get into a closer conversation with their code, right? Where, and it goes hand in hand with deploying really fast and often having
mm,
smaller services so that teams can have more ownership over a small, like a greater degree of ownership over a smaller sort of surface area. But like the end goal is to be able to ship code many times a day, to be able to tell in a glance whether or not something is working, to be able to flip feature flags on and off to control whether or not your users are seeing it, to be able
yeah.
to decouple deploys from releases. There's a lot that goes into it. So I think the tool really matters, but it's far from all that you need.
Yeah. And do you think this is an investment that pays off? Since we have said that it's not only the tool, it's about the process, the building the model. You made the analogy with the business intelligence. So do you think this is an investment that pays off once you get to a certain scale in terms of, I don't know, team size or
Mm-mm.
traffic, or is it one of those things that the earlier you do it, the better? It's an investment that you can do even if you're a smaller team.
The earlier you do it, the better. The thing is that like one thing, a refrain that I hear very often is, "Oof, we haven't even mastered 1.0 yet. I don't think we're ready for 2.0." And I just want to shake people because the way people are doing it now is the hard way. It is
Yeah.
so hard trying to fit, the questions that you need to ask into these very, compacted, dense, difficult, non-relational data types like metrics and tags. It is like I hear from so many observability engineering teams that are spending more time, like an outright majority of their time, trying to manage costs on an ongoing basis, not writing libraries, not enabling their teammates, not creating value for the org, but just trying to manage the seething complexity of the metrics based tools. It is so much easier and simpler to just treat your telemetry data like data, to just be like, here's a data blob. I know how to do, I know how to sort, I know how to query, I know how to connect things. I know how, it, and having the data with the connector tissue in that way opens up the window for just like things that feel almost magical. So this thing that everybody's always like, well, what about AI? And I'm like, we don't need AI. We just need normal computation. Like Honeycomb does this thing that's called bubble up, where if you're gathering your data in these wide events, then if you've got your SLO or any heat map, any graph where you're like, that's weird, I want to understand that. You draw a little bubble around it, and we compute for all of the dimensions inside the bubble versus the baseline outside the bubble and sort and diff them. So whatever you drew a thing around, instantly you're like, all the things that are different about the data that I care about. So like so many of the problems we have to debug are like, okay, this thing gets tripped when it's Android devices running this build ID, using this language pack from this region, using this application,
Yeah.
just like 10 different things, right? And it's just a blip on the thing, but it's a really big deal for a small number of people. And when you have all that context, you can just identify instantly what's wrong with it. So much of debugging boils down to here's the thing I care about. How is it different from all the things that I don't care about?
Yeah, yeah, I love the answer, and I love that you said we don't need AI for many things. We think that we need AI for everything. Like instead, sometimes just good computation and good traditional technology is more than enough. So I was wondering why you were talking, right? You were talking about all these use cases by teams using observability strategies and platforms. So when you think about teams that have implemented, that have gone this route successfully, how do they, I mean, what's their daily life? How they use these powers, let's say? Do you have processes? They use them, of course, for maybe in a reactive fashion for incidents, but maybe they're also proactive in discovering things. Should you create processes to take advantage the most of all of this?
Yeah, absolutely. That's such a great question. I think of this as kind of the second coming of TDD. Like,
Mm,
when it used to be that QA ran all the tests, right? And engineers just wrote code. And then we were like, wait, we actually build way better systems when the same person writes the tests and the code. And yeah, there's still a need for QA folks to be like experts to like help us level up. But but software engineers should understand the code that they're writing. Well, the thing about tests is they're not going to tell you if your code works or not. They're going to tell you that it's probably logically correct at best. They stop at the border of your laptop, right? They're not going to tell you whether or not it's actually working for people. And so I feel like this is just really kind of the next wave of that, where instead of writing tests as you write your code, you learn to instrument your code as you write your code. And you learn to like get it into production while you still have all that context in your head. And your job is not done until you've looked at your code in production through the lens of the instrumentation you just wrote. And you're asking yourself, is it doing what I expected it to do? It's doing what I want it to do? And does anything else look weird? Because that moment, you know what you built, you know why you built it, you know how you built it, you know what you tried that worked, you know what you tried that didn't work, you know what the functions are named, you know what your variables named, you know everything. And like, if we just like merge our code and walk away and start working on something else, we like we starve ourselves of the best hope of we will ever have of finding that stuff before our users do. And so like I feel like a lot of this is about learning to just like close that loop and like feel ownership over your code until you watch users using it and you're like, until you have some confidence that, yeah, this is what I wanted to do and it's working. So like every company that I've seen go through this process also comes up with other processes and tools and habits and stuff, because every engineering team is unique, every use case is unique, every, there's a lot of sort of historical precedence that goes into this. Um, but like at its basis, like that's what, I don't know if you've seen the data that shows that the cost of finding and fixing bugs goes up exponentially from the moment that you write them.
Yeah.
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 So like
Of
I
course.
feel like there's all this dark matter in software engineering that makes us frustrated. Why can't we move faster? Why does it seem to go so slow? Why can't we ship more product? Why can't we do more with what we have? And I feel like all of this dark matter, it's so hard to see the things that we can't see. And so much of the stuff that we can't see is that connective tissue that we're throwing away when we write our data out into metrics and we can never get it back again.
Yeah.
We spend the rest of the code's life cycle trying to guess what held it together, trying to like reconstruct our mental model of what was happening. And if we just preserve that data, then we can go to the source and ask about it, and we can observe it, and we can see what's happening. And it makes everything so much faster and easier.
Yeah, I love the focus on ownership, and I want to segue this into talking about testing in production because you have mentioned it. But before we do, I want to pick up this question by Matteo, who asks, are there tools that are actually replaced by Observability 2.0, or it is just adding things on top of the things that you already do? So you implement such a solution, and maybe you don't do this and that anymore, or you just
Yeah,
keep all the other things as they are.
it's a great question. And it's a very fair question, because right now, I think the biggest sort of lever that we've seen is the unsustainable cost crisis. And so, like, what are going to people add one more
Yeah.
expensive tool? Yeah. No, the answer is, of course, of course. I think that Observability 2.0 tools should replace most of logging, other than the security use cases, which you should be able to just kind of archive in something very cheap. It should replace
Mm.
90% of what we're using metrics for today. Metrics still have a use case for infrastructure and for archive and summaries of a large amount of data, and tracing absolutely should be replaced. So it's kind of hard to talk about this. I try really hard to speak in vendor neutral terms, and it's sometimes challenging because I think Honeycomb is kind of the only 2.0 vendor out there right now. I think that Lightstep kind of gets close. I think that Baseline is really interesting. I guarantee you that there are more on the horizon. So it's challenging for me to speak from a vendor perspective versus but from a vendor perspective, like today, Honeycomb often replaces like all of New Relic, most of Datadog. Uh, it's really easy to replace like logging use cases, especially if people have done structured logging. But I will also fully own that like the tools like Datadog out there are 30 years old. Like they're complete in a way that tools that are only 5 or 6 or 8 years old
Yeah.
can't be yet. And so in some ways, I feel like this is the question that teams that have kind of, this is why we don't talk to many people who are like deep in firefighting mode right now. We talk to
Yeah.
teams, we talk to a lot of platform engineering teams, we talk to teams that are kind of out of that state a lot, and they're planning for the next year or 2 or 5 years. And they're looking at the cost growth and they're going, well, that's not going to work. And they're
Yeah.
looking at how much time their engineers are spending firefighting and stuff. And they're like, well, that's not going to work. And so even though something like Honeycomb can't today replace all of the use cases, they're like, well, 5 years from now, 3 years from now, 2 years from now, this is the trajectory that we're
Mm.
on. And I think I can say that in a very vendor neutral way. I think that Observability 2.0 will eventually be the only tool you need to understand the intersection of your software and your users. I think there are still
Yeah.
going to be niche use cases for, infrastructure teams, for archival and stuff, but I think the core use case of understanding your code, that's an Observability 2.0 shaped problem.
Yeah. And speaking of costs, how you should think about them? Should you think about the observability costs like as a function of your infrastructure cost? And do you have like benchmarks about how much teams should spend on this?
I so all I have are opinions. I have opinions. I will say somewhat defensively, I had these opinions before I started an observability company, and they haven't changed much. I remember saying 10 years ago when I was at Facebook, I was like, pretty much across the board, what I see is really good teams spend about 20% of their infra costs in observability.
Okay.
Um, I think that can be lower these days. I think 15% is usually about what I see teams that are really on top of it and have really good instrumentation. Obviously, there is some variance there. I think that there are some kinds of technology, like spray and pray, like ads, where you
Yeah.
can get away with like 10% because you don't actually care about every. But if it's like delivery companies or banks or anything where you have dollar values attached to every single outcome, I think you're looking at 15 to 20% of your infrastructure bill and observability costs.
Yeah, that's a very practical answer. Thank you. Thank you for that. I think, yeah, it pretty much depends, but even having a ballpark, I think it's very useful for people to understand, where am I in this in this spectrum,
For sure. And
Uh,
I will also say that I have had many people come up to me very indignantly and go, well, that's a vendor question. We only spend 5%. And every single time when I dig into it, yeah, that's how much they're sending to another vendor. But they are spending way more than that on engineering salaries to do that stuff in house.
Yeah, yeah, it's always the case. So before you said something about testing in production, right? Because with good, one of the things that come easier with good observability is good testing in production, and this is always a controversial topic because I think that people conflate this with thinking that they should only test in production, while instead
Right?
it's of course you also test in production, right? So what do you mean by testing in production? And what I mean, back from the basics, why should people do this at all? Like, why isn't staging enough, for example?
Well, first of all, I don't think this is optional. I think every engineer who has a production environment is testing in production. It's only some of us that admit it.
Yeah,
Some of us are like, no, 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 we
I
never tested
agree.
prod. And it's like, okay, sure, I believe you. I think that the first step to doing it well is admitting that it has to be done sometimes. And that lets you have a better conversation about when it's appropriate and what the trade-offs are and what you can hope to find in staging. And then, you know, there are really interesting conversations to have about how to do it non-destructively, how to do it safely, how to do it securely, how to do it using things like feature flags or progressive deployments or synthetics or there are all it's testing in production doesn't just mean YOLO. Just push it to prod
Yeah,
and see what happens.
exactly.
It's like to some extent, if you aren't incorporating production into your testing, that's really scary to me because no matter how good your staging development environment is, it is never going to be exactly like production. It is not possible. It is not possible to have the same concurrency, the same chaos, the same variability, the same, because every moment in production is unique. That's kind of what makes it production. And so I think
Yeah.
that like finding ways to smear the development process, smear the operational process to the one side and smear the testing process to the other side. Like, this is why I think that it was. I think of like dev versus ops as being like the original sin of engineering. Like once upon a time, we
Mm-hmm.
thought it made sense for half of our engineers to write code and half of our engineers to understand their code, and that was just not smart, right? And so I feel like we've gone through this whole like sort of like reconciliation process of like, okay, dev and ops can work together, and now it's like, okay, actually, ops doesn't exist anymore, except operations is more important than ever. But like the world that we should live in is one where every engineer writes code and every engineer owns the code that they write. And there's lots of
Yeah.
room for specialists to help us all do better, because you can't expect your average software engineer to know everything. They're completely right. That's not a reasonable request. But you do need to know enough to do a good job of writing software, and then rely on experts to help you operate it and test it and scale it and so forth.
Yeah, yeah, I totally agree. And do you think that with good observability, with good testing in production, teams can even go without an intermediate environment, go without a staging environment, and have a continuous delivery process that doesn't require like middlemen like that? I know it
It
depends,
depends.
of course.
I know, you know. I mean, so like there were so at Honeycomb for a long time we just had production, and then we were like, okay, well we need to be able to monitor production. So then we have a dog food cluster, and now we have a kibble cluster. So uh, production data goes to dog food, and dog food data goes to kibble, and we use all three. And we also have staging environments that like our designers use, because designers have different needs than engineers. They need to be able to spin something up, and see it. So I
Yeah,
think I think it's a really good practice to minimize the number of environments you have to maintain, because every environment comes with an overhead, sometimes a pretty substantial one. I think that there are
yeah,
I think that there are companies that might surprise you that have no staging environment at all, but they're not slap happy about this. It means that they have spent years, sometimes decades, in investing in their production tooling. So it really depends. Engineer The reason that I started ranting about testing and production, to rewind the clock a little bit, was because I felt like I was seeing, like, every company has a limited number of engineering cycles to spend. And I felt like I was seeing so many companies get so wound around the axle in the idea that they could prevent problems from happening. And they're devoting such a large percentage of their
yeah,
precious cycles to trying to find things before they got to production, that they were starving their production systems of the tools that they needed to find the problems there. And so that's why I started talking about testing and production, to just be like, look, it's impossible to find everything. We need to invest in our production toolkit so that we can find them swiftly and easily and safely. So I'm not actually like preaching against staging environments so much as just like arguing for a balance.
yeah. Yeah, I think it's a sensible question because there are, this is one of the divisive topics where there are people who said, you should do this, you should do that, and this is like the absolute truth. While instead, of course, things are more nuanced. But I agree that you should, minimize the blocking parts of the process, of the delivery process, as much as possible, and
Yeah.
have a swift release and delivery process. So I know you have talked a lot about this in other talks and articles. So what does a good continuous delivery uh, process and pipeline looks like to you in terms of steps, times? What should the life of a developer be ideally for that? I know it depends on systems, it depends on use
Yeah.
cases,
Yeah.
but what's your take on this?
I think the most important thing is to be able to get code out in real environments, in a small enough amount of time that you still have all that context in your head, that you don't have to like page
Mm,
everything in and out, just swap to another project or whatever, that you should be able to like be shipping and testing your code. I've said some very big things about like 15 minutes or bust. I think 15 minutes is a great goal. I think an hour is fine. I think that longer than that starts to become less and less fine. I think you
yeah,
obviously want to do code review or pairing. You obviously want to have a pipeline. You obviously want to, run your battery of tests. I think it's really nice to have some sort of progressive delivery component. At Honeycomb, what that looks like is it automatically gets deployed to kibble, and then an hour later, if nothing catastrophic happens, it gets promoted to dog food. Hour later, it gets promoted to production. I think that if there's like a golden rule that engineers should strive for, it's that once you merge your code without doing anything, it goes live. I actually think it's more important that that happens
Yeah.
predictably than that happens in a very short time interval. I think both are fine, short time interval or that it happens predictably. But I think that having it happen predictably means that, like, psychologically, you just know that it needs to be ready to go when
Yeah.
you hit merge, right? And you know that it's going to go live. And that should be the assumption. It should feel like an atomic operation in some sense, right? And then you should know that your job isn't done until you've looked at it in production and you've checked yourself against your instrumentation. Because,
Yeah.
and I feel like observability driven development is a term that I like. I feel like 2 or 3 years from now, maybe 5 years from now, I think there's going to be a richer tool set around this. It's not just manually like checking your instrumentation in production. I think we're going to see some really interesting stuff there. I think we're not quite there yet. But like the most important things are, getting it out fast. Because when you don't get it out fast and when you don't get it out automatically, you enter what I think of as like this software engineering death spiral where everything starts taking a longer
Mhm.
time. But it takes a longer time, so code reviews take longer, so your disks get larger, so people back up more, so they end up switching projects more, so they end up waiting on each other more.
Yeah.
Then you need a release engineering team and SRE team, and
You
you
batch
start batching
releases.
out.
Yeah.
Yeah, you start batching out a lot of people's changes at once, and then it's just, and this is where the dark matter comes in, where it's just like, why is everything so slow? Because we're going as fast as we can, And I feel like, our teams, these are systems, right? And they're comprised of feedback loops. There are two kinds of feedback loops, actually. There are reinforcing ones, and there are leveling ones. There are ones that sort of like balance each other out, and then there are ones that amplify each other, right? And the process of writing and shipping code is such an amplifying feedback. If it's short, everything downstream of it becomes shorter and faster and easier and quicker and
Yeah.
funner. And if it's long, everything downstream is so painful. So I really do think that these systems are incredibly complex. It can be very hard to know where to start. A lot of really good, smart people have gotten kind of bogged down in trying to change culture and change practices. But I think that that interval between when you write the code and when you can look at it in production, I think that that's like as close as you're going to find to like the golden key to unlocking high performance.
Yeah. So what we're saying is that taking from the answer from before is that you should test your own code in production, and to be able to do so effectively, you have to retain that context in your head when you do so, and to have that context in your head, it needs to have passed just a little time from not too much time, let's say, from when you push the code to when it's up there for you to figure out if everything works well. It's what we're
Yes,
saying.
yes,
Yeah.
exactly.
And what are in your experience the most common offenders to this? I mean, the most problematic areas that are always the same that people should maybe start from to work to improve
Ah,
the delivery.
good intentions. you know, I say that jokingly, but like it's a physiological fact that when we get scared, we freeze, right? We want to slow down and get
Yeah.
more control over things. And so I feel like when things feel flaky, when they feel out of control, when they feel, we add more process, we add more tests, we
Yeah.
add more stuff, we add more layers, and we don't realize that we're killing ourselves. And
Yeah.
it's all done with the best of intentions. And it's often incentivized by, outside forces that are like pressing in and adding pressure, and we're just sort of reacting to them. And it really is hard. And this is why I think this is the job of engineering leadership. It doesn't matter if you're a manager, director, IC, or whatever. The job of engineering leadership is to show, not tell. Is to show how move. There's this. I don't remember who said this quote, but I love it. And when it comes to software, you would either have better software faster or worse software slower. And so, like, I think that we really have to like enter into these fights remembering that everyone is trying to do their best and everyone is fighting their own battles. And it's just human nature that all of this stuff slows us down. And the only way to start hacking away at it is to start, showing instead of telling, start peeling off little bits, start showing progress, start getting people excited, start building champions, start showing what can be done. And then, I feel like the superpower of engineers is doing, right? Every other role in the company
Mhm.
can talk about our work, only we can do our work. And so often I feel like I've seen these log jams get burst by a senior engineer who is just willing to take a couple days or a week, build something, and just show everyone, look, it can be done.
Yeah. Yeah, I love this positive take. My feeling is that we start losing the thread when we spend too much energy on trying to preventing things
Yes.
rather than being able to recover fast. Embracing mistakes because they happen anyway, and but being
Yes.
able to recover faster from them. I mean, you start getting afraid that something
Yeah.
bad happens, and because in the back of your mind, you know that when bad things happen, you are slow at recovering from
Yeah.
them.
Yeah.
That's my feeling. Yeah.
No, I think you're 100% right about that. And this is what I feel like. So the first few years of this bit of a diversion, but like working at Honeycomb the first few years, it was so miserable. Like it's building a startup, like it's just not, it's so unhappy. But like I feel like it's good training to be working in distributed systems because what I've always said about you're working on systems, they're constantly degraded. They're getting worse all the time. Your systems are constantly failing. The fact of the matter is that most people don't have good enough observability to tell just how bad they are. Like when people start rolling out Honeycomb, one of the most common reactions is people are like, "Oh, that's broken. Oh my god, that's airy." Oh, and we're just like, "Yeah, you know how long it's been this way? Forever. Let's just like get through it and like be done with it," because people
Forever.
just don't have the ability to see what's happening. They're, this should make everyone feel so much better because our systems are already resilient to so much stuff, right? And this is great. This is, and honestly, I feel like the appropriate attitude towards failure is humor. Just like it's really kind of funny. We're naked, hairless monkeys up here on this spinning ball, just like poking at shit we don't really understand. And we made this world that's like so complex and crazy and weird and fun and awesome. And I feel like an attitude of humility when it comes to software and just like curiosity is the cure to so much of this just like sort of fear and calcification like you were talking about.
It's true. It's true. And do you use Honeycomb to build Honeycomb? That's I mean,
Absolutely.
fair question.
Absolutely.
So
Don't know
you
how we do it.
otherwise, yeah. I mean, it's such.
Yeah.
I'm always envious of teams who work on products that can literally the 100% dog food and can be
Yeah.
100% their own customers. It's like a superpower.
It really
I don't know
is.
if you agree. I mean, in your experience, because it improves the feedback loop in a way that is like incomparable to I don't know other things that you might do, and I think it's a great experience. But you tell me.
Yeah, you're absolutely right. And this is, one of the fun things about being at Honeycomb for the past few years is I feel like we've been sort of on the vanguard of so many sort of dovetailing trends in technology. And one of the ones that makes me happiest is, when I was a kid, as a baby engineer, it wasn't cool to care about the business. All of the cranky old engineers were like, we're all about the technology. We don't care about the product. And that's not the way things are anymore. It's really expected that the best engineers are ones that care about the business and the product and the users. And
Yeah,
I think that
yeah,
I think that's so healthy and so positive. Dan Pink wrote that book about what we all want out of our work. It is autonomy, mastery, and meaning. And the
yeah.
meaning of our work
Yes,
is not
exactly.
bound up in what kind of data formats we're using. It's bound up in the impact it has on the users that we're serving. And I feel like there's this virtuous feedback loop of the more closely you can align and care and be curious about your users. Yeah, it's great when your users are also yourself. That's like a cheat code.
Yeah, yeah. I love you mentioning that how the engineering role is broadening, like to take care of more and more things. And you have said before that in the early days, dev and ops would be totally different things. And now it's not only that we have DevOps, but we have engineering that are rewarded for taking care of the business, for thinking about the business. We have product engineers, like we call them like that, right? And do you think like this is a trend that will keep? I mean, even maybe with more productivity, AI helping engineers, we will have more and more empowered engineers who are full stack, not just in the sense of technology, but in owning like vertical slices of the product and so the business.
I do. I mean, I think you can make a it just occurred to me, but I think you can draw a pretty decent metaphor between software development and computers writ large. 30, 40 years ago,
Mm,
computers were a tool that only computer people use to do computer things.
yeah.
And now it's a tool that everybody uses for their daily lives, you know? And so I think that like the question of is anyone going to still need to write lines of code? I think the question is yes and, right? I think that no code, low code is going to get more powerful and more prevalent. But at the end of the day, there's always going to be the need for people to deeply understand our systems. We are legally and ethically held accountable for the code that we put out into the world. We have to be able to understand it, right? And so, well, 20 years ago, every software engineer had to understand how disk drives worked and memory worked. And, you had to, when you're writing Hello World, you had to allocate memory and reap the memory. And
Yeah.
like, very few engineers need to understand that. Now, some do, very few do. Most of us have kind of moved up the stack. There's like this, level of abstraction that has sort of changed, and I think that's going to continue to happen. There's nothing that we aren't eventually going to need to understand.
Yeah, it's true. It's true. The level of abstraction keeps getting higher and higher, even though it feels like with the most recent AI developments, it's kind of a different thing because I mean I've been thinking about AI as the most recent development in engineering, how it changes how people work, and it feels slightly different from the creating a higher level language, for example, right? Because in a way you're still dealing with the same level of code that you were doing before, but you're being more productive because this code gets generated somehow. Unless we will start I don't know version controlling prompts, but I don't feel will happen anytime soon. But yeah, this I just me rambling. I don't have a position on this. I don't know if you ever been thinking about this.
I have, and in some ways, I think it's kind of unfortunate that all of this early generative AI stuff is focused on generating lots of lines of code really fast because that's not the hard part. Like everybody thinks of like writing code as the hard. It is
Mm,
not and has never been the hard part of software systems. The hard part is understanding them, maintaining them, extending them,
mm,
making them tractable, and I think that there are practical applications for AI when it comes to the other side too. Like one of the engineers I work with is like, I use generative AI every day, he says, and it's like having a really energetic, enthusiastic junior engineer that I have to keep like just like saying settle down because they generate all this code, but you still have to go through and like understand it and make sure it's
yeah.
formatted and make sure it's like modularized and all this stuff. Like the understanding of code is the hard part. And so like, yeah, of course, 10, 20 years from now, who knows what it's going to look like. But a lot of the
Yeah.
thought leadership and futuristic thinking about AI right now, I just don't see it changing in the ways that they're claiming it's going to change because we still have to understand our software, and that's still the hard part. There are two types of tools. There are tools that obscure complexity and tools that help us manage complexity. Honeycomb is very much a tool that tries to help you manage complexity. And I
Yeah.
feel like so far, the generative AI tools are just like, wee complexity. Like
Yeah.
that's not really as helpful as you think it is.
Yeah, I think it's particularly important that you mentioned that maintaining, understanding, and evolving code is like probably the biggest chunk of the work eventually, for any part of a system or a code base. Because um, and I feel with generative AI, what happens is that you're like maybe 10 times, I exaggerate, 10 times faster at writing code, but the risk is that you're then 10 times slower at maintaining it because it's not code that you have written. I mean,
Yep.
when you have to debug that code, you're incredibly slower than you are
Yep.
when it's your code. So it's not clear cut what is the net positive. Yeah, of course, it's a net positive overall, but it's probably less than what people think eventually, over the long run.
Yeah. There are use cases for write only code. Agencies like disposable apps. Like there are use cases for that, but that's not most of the code that runs the world. I will say that I'm worried for junior engineers. Like the state was already not good before generative AI came along. Like so many companies
Mm,
out there are so short sighted. They're like, oh no, we only want to hire engineers who are senior who can like jump right in and get started. Nobody jumps right in and gets
yeah.
started. Like it takes a while. And have you ever been in a team of all staff and principal engineers? It's fucking miserable. It is not a good team. You need range of levels to have people
Yeah,
who
it's
are
true.
asking questions, people who are answering questions, people. The most productive engineers in terms of like generating features are rarely your most senior engineers. They're usually the intermediate engineers, the ones who aren't yet being dragged into all the meetings and planning and everything. They're just able to sit down and write software. And I feel like the best, like the most senior engineers are rarely the best coaches because you really want someone to mentor you who's only 2 to 5 years ahead of you, you know? So I feel like, yeah, there's an upfront cost to hiring junior engineers, but it's not as big as people think it is. And there aren't just long-term arguments for doing it. There are really good short-term arguments for doing it too. Junior engineers are so grateful. They're so thankful, and they're so loyal typically, and they ask great
Yeah,
questions.
yeah, it's
They
true.
bring energy. They bring new ideas.
Yeah.
You know, I feel like there's this tendency now to just go, well, AI can do it, and that's really stupid because at the end of the day, nobody is arguing that we're going to need fewer senior engineers. Nobody. And how are we going
Yeah,
to
yeah,
make
no, I
them? I
agree.
don't know.
I agree 100%. I mean, I've long argued that junior engineers make your teams better because otherwise, as you said, if it's all staff plus engineers, super senior engineers, it's kind of things kind of degrade over time. The fact that there are junior engineers keep your team from taking too many things for granted. I don't know how to say. You know, you see that people write less and less docs. Maybe they just know how they do things. I mean, they don't care. Instead, the fact that there is somebody who's learning, somebody who has to understand how you're doing things, it's like that
Absolutely.
keeps them at a higher standard. You know?
100%. And it's more fun. I mean, I think that fun is undervalued as a work value because, you know, a really happy, healthy team is one where every single member is being challenged, is pushing their boundaries, is
Yeah.
growing, is doing new things. If you have a team full of people who are all super jaded, who have all built a login form like 1,000 times and everyone's bored by it, nobody's going to do a good job. You want someone there who's like, I get to build a web form? Oh my God. I mean, it's so much more fun to be working with people who
It's
are
my
all
first
being
time a
stimulated.
web form.
It's my
Wow.
first
Yeah.
time. I know. It's so energizing for everyone.
Thank you, Shay. I think this was a perfect parting topic for this chat. So we're gonna wrap this up. Thank you so much for this, and I love this conversation. I mean, my only regret is that I would have loved to have like 5 hours to talk
I
with you
know.
about pretty much everything. So thank you again.
Thank you so much. This was really fun.
Thank you so much for listening. If you found this chat valuable, you can subscribe to the show on YouTube, Apple Podcasts, Spotify, or your favorite podcast app. Also, please consider giving us a rating or leaving a review, as that really helps other listeners find the show. You can find all past episodes and learn more about the show at refactoring.fm. See you in the next episode.